Okay, so in this example, we're being asked to find the remaining trig functions of the angle. Notice here that we're given cosine theta, it's going to be 2 over 3, and tangent theta is less than 0, or in other words, it's going to be negative. Now, there are two different options you can use to solve this problem. Let's go over option 1, and with option 1, we're going to go ahead and just draw out a coordinate grid. So we'll have something like this. And we just want to determine where our angle is occurring. Is it occurring in the first, second, third, or fourth quadrant? So we're going to do that based on the information that we're given. Notice here that cosine is positive. And we know that cosine is positive in both the first and the fourth quadrant. Okay? We also know that tangent, right, is going to be less than 0 or negative. And tangent will be negative if we look at the first and fourth quadrant. Well, it's going to be positive in the first quadrant, and it will be negative in the fourth quadrant, meaning our angle has to be in this fourth quadrant here. So knowing that, we can go ahead and draw in our angle by putting in our triangle, right? That's going to look something like this. And we can put our angle theta, and there it is. So at this point, you want to go ahead and fill in the sides of your triangle. We're given cosine, which we know is adjacent over hypotenuse. So adjacent here is going to be this length. So we're going to have 2. And then our hypotenuse will be 3. So notice what we can do here. We want to find this missing side length here. So we're going to use Pythagorean theorem. And in order to do that, we're going to do the following. We're going to do 2 squared. We'll just call this x, this side we're missing. So plus x squared equal to 3 squared, so this gives us 4, plus x squared equal to 9, minus 4 on both sides. You get x squared equal to 5. And now you just want to take the square root on both sides. So you get x is equal to plus or minus the square root of 5. Now notice here we are given two different answers. We're given plus or minus, so you need to choose which one to pick. In this case, we're going to pick the negative because, again, we just found this length right here. It is going to be negative because tangent, right, needs to be negative. We know that cosine is positive. So tangent is sine over cosine. So if cosine is positive, that means sine has to be negative in order to give us a negative tangent, right? So again, we're going to pick the negative one, all right? Now, let's go ahead and find the missing trig functions of the angle. So we're going to go ahead and erase this. We're done with this. And let's just start finding them. So we're going to say sine theta equals, well, sine is opposite over hypotenuse. So in this case, opposite over hypotenuse, that's going to be negative square root of 5 all over 3. Cosine we're already given, but we'll write it in. It's going to be 2 over 3. All right, and then tangent, we said before, is going to be sine over cosine. So here's sine, here's cosine. So we're going to have something like this, negative square root of 5 all over 3, and then all over 2 over 3, which we know is really negative square root of 5 over 3 times 3 over 2, right? This goes back to keep, change, flip. 3's cancel, and you're left with negative square root of 5 all over 2. So there we are. Now, the other 3 missing trig functions will be fairly simple to find, right? Because all we have to do is flip. So for example, let's say we want to find cosecant now. So cosecant theta. All we're going to do is go to sine, and we're going to flip it. So we have now 3 over the square root of 5, and again, this is negative. Now the only issue here is you don't want to have a square root in your denominator, so we need to rationalize it. So we're going to multiply both the bottom and the top by the square root of 5, and this gives us negative 3 square root of 5 all over 5. So that's what cosecant is going to be. So we get negative 3 square root of 5 all over 5. Okay, let's find secant. So in this case, we just go to cosine and we flip it. So now it's 3 over 2. So that one was easy. And then our last one that we want to find is cotangent. So in this case, we go to tangent and we flip it. So it's going to be very similar to what we just did here. So we're going to go to tangent, flip it. So 2 over the square root of 5, again, will be negative. Again, we need to rationalize the denominator here. So times the square root of 5 on both the bottom and the top. Negative 2 square root of 5 all over 5. So that is what cotangent is going to be. Okay, so we just found all of the missing trig functions of the angle, right? So we just went ahead and boxed them in. So that's option 1, right? Let's go over option 2, all right, how you could solve this problem. We'll do that fairly quickly. So let's erase this. For option 2, you can use an identity. And that identity is going to be the following, where you have sine squared theta plus cosine squared theta equal to 1. And then you're just going to go ahead and fill in your information. So we have sine squared theta plus, well, we know cosine is going to be 2 over 3. So this becomes 2 over 3 squared equal to 1. And then this continuing on, sine squared theta plus, this is going to be 4 over 9 equal to 1, minus 4 over 9 on both sides, so you get sine squared theta equal to 1 minus 4 over 9. All right, we want to combine these terms here, so let's do that off to the side. We have 1 over 1, all right, just rewriting that, minus 4 over 9. So what you want to do here is get a common denominator. So to do that, we simply just multiply the denominators and we get 9, right? 1 times 9 is 9. And then you say to yourself, what did you multiply this by in order to get 9? Well, you multiply by 9. So 9 times 1 is 9. Okay. What did you multiply this by in order to get 9? You multiply by 1. So 1 times a negative 4 is a negative 4. And you can see here how you're going to get 5 over 9. So let's go ahead and write that here. Sine squared theta equals 5 over 9. We're almost done. So now just taking the square root on both sides, we get sine theta equal to plus or minus the square root of 5 over 9. And then just simplifying it one more time, we get sine theta equals plus or minus the square root of 5 all over 3. So you can see here, we just figured out what sine theta was, right? It's right here. Again, you would have to determine that you're going to use the negative one here. We went over how to do that. Okay, and you can see that we get the same thing here. And at this point, you would just continue on finding the remaining of your trig functions of the angle. Okay, so those are 2 different options that you can use. All right, and that is it.